So in the previous lecture, we discussed about research design part 1. Under research design part 1, we discussed all these points. That is, what is research design, functions of research design, theory of causality and research design, differences between quantitative and qualitative study designs, and we started with study designs in quantitative research. So these are the points which we discussed in the previous lecture. What is research design, functions of research design, theory of causality and research design, methods of elimination of extraneous variables, differences between quantitative and qualitative study designs. This is the classification of research designs in quantitative research. And we discussed about first classification, that is based on the number of contact points with the study population. And that is cross-sectional study when we have 1 point contact before and after study, 2 point contact with the study population. And longitudinal study means 3 or more than 3 point contact with the study population. In today's lecture, we will start with the other topics like from reference period of the study, that is from retrospective, prospective and retrospective prospective study designs. We are discussing our second classification, that is reference period of the study. So second part of our classification, that is based on a reference period of the study. Quantitative research design in quantitative research are retrospective study design, prospective study design, and retrospective prospective study design. The first is the retrospective study design. Now, retrospective studies investigate a phenomenon, situation, problem, or issues that has happened in the past. So retrospective means you go in the past and you collect the information. So information of the past. Now you are in the present, and when you collect the information of past, that is called as retrospective. Retro means going in the past and collecting the information. So at this moment, you have planned your study and you want to collect the information. So what information you will collect? You will collect the information of the past. So at this point of time, you are here, primary or secondary data collection. Your study population is here. And whatever aspect you are studying about your study population, or whatever aspect you are studying about situation or phenomenon or condition, that you go in the past. Go in the past means you will collect the information of the past about that particular study population or situation or phenomenon or condition. So data of the past is collected, and that is called as retrospective study design. Suppose my research problem is I want to assess the impact of electric vehicles on air pollutants. Now what I will do, suppose I want to assess or I want to check what is the impact of petrol and diesel vehicle on air pollutants, or how much amount of air pollutants are released because of petrol and diesel vehicles. So what I will do, I will collect the information of the past. Past information means under retrospective study for last 3 months, whatever data is available on the ministry website or maybe a government website or other websites where I can get the information about air quality or air pollutants. So suppose if I take information for last 3 months, then that will become my retrospective study design. Like retrospective study design means secondary data that is collected from some sources. So what I have done for my study, I have collected secondary source data from the website, from the available records. So whatever records are available from that records, I fetch the data so that I will have entire idea about what was the impact of these particular vehicles, maybe petrol vehicles, diesel vehicle, or maybe some other vehicles for last 3 months. How much air pollutants those vehicles have released in last 3 months. So that impact or that value I will get for last 3 months. So that is a retrospective study. So again, retrospective studies investigate a phenomenon, situation, problem, or issue that has happened in the past. So whatever has happened in the past, the data of the past, whenever you collect the data of the past, that is your retrospective study design. Conducted either on the basis of the data available for that period or on the basis of respondents' recall of the situation. So it is based on what? It is based on the data which is available for that particular period, or it is based on the respondents' recall. Like if you are dealing with the human population, so what if you're talking to human population, whatever they remember of the past, okay, whatever past data they remember, or whatever past events or situations or phenomena they remember, that data is collected, and that data is based on their recall of the situation. Suppose you are studying some situation. Okay, like Bhopal gas tragedy. If you are studying a Bhopal gas tragedy, that has happened long back. Long back means it happened in 1984. So if you're talking to the respondents who were the part of that Bhopal gas tragedy, you are collecting the information of the past. So whatever respondents are recollecting, whatever respondents can recall about that particular situation, that is taken or that is noted down, and that is called as a retrospective study design. Okay, so what do you understand by retrospective study design? You are here in the present and you want to collect the data of the past. How do you collect the data of the past? So it is based on the It is based on your study population. If you are dealing with a study population, you will ask questions to the study population about that particular situation, phenomena, which has happened in the past, and you will collect the data. Or if it is some other, if you are not dealing with study population and you have some situation or phenomena, you will collect the secondary data, right? And that is called as a retrospective study design. The examples of retrospective study design are the living conditions of Indian population during British rule. So British rules means long back. So what was the living conditions of Indian population during British rule? When British was ruling India, how was the living conditions? And if you have some people, or if you come across the population, if you come up across the people who were part of that era, you can ask them questions, right? You can ask them to recall the situation. You can ask them to recollect what the information, and whatever the information that study population will recollect about the living conditions of Indian population during British rule, you will note down. Okay, means you are going in the past, you are going in the era of British rule. British when ruled India, you will go into that era. You will ask your respondents to go into that era and recollect whatever information they can give about that particular situation or condition. A historical analysis of migratory movements in India between 1947 and 1950. So the migratory movements happened in India between 1947 and 1950. So many people were part of these particular migratory movements, right? And during these migratory movements, whatever events happened, if you are dealing with a study population, if you are dealing with a study population who were the part of that particular migratory movements, if you ask them questions, if you collect the data from them, whatever data they recollect, whatever data they can remember, they will tell you, and that data will be written by you, or that data will be noted by you, and that is a data of past. So it is called as a retrospective study design. The relationship between the levels of unemployment and the street crime. So for the past 1 year, so or past 3 years or past 5 years, so I can study or government can study what is the level of unemployment in the last 5 years and what are the number of street crimes. So what was situation 5 years back, 4 years back, 3 years back, 2 years back, and what is current situation. So government is doing, or organization is doing, what organization is collecting the data of the past, and they are finding the association between unemployment and the street crime. Okay, so then it is a retrospective study designs. So these are the examples of retrospective study designs, or these studies, this kind of studies you can do in a retrospective manner. That is, you are going into past and you are collecting the data. Now coming to the next part, that is prospective study design. The prospective studies refer to the likely prevalence of phenomenon, situation, problem, attitude, or outcome in the future. So whatever is going to happen in the future, that data when you collect, or that data when you are plan to collect, that becomes your prospective study. Like in my case, I want to assess the impact of electric vehicles on air pollutants. Now, if today I start the study and I follow it for next 3 months, like April, May, and June, if I follow it for next 3 months, at the end of June, if I analyze the data. So that becomes my prospective study going towards future. So today I am starting the study and I will collect data for next 3 months. So I am going in the future. Going in the future means my study is going from present towards future. Okay, previous study, that is retrospective study, we were collecting the data of from present, we were going in the past and we were collecting the data. In the prospective study, we are in the present and we will collect the data of future. So in the future, we will go in a prospective manner, and for every day or as per the study design, we will collect the data. So what are these prospective studies? Basically, data of future is collected. We are in the present and data of future is collected. So prospective studies refer to the likely prevalence, total outcome of that particular situation, phenomenon, problem, attitude, or outcome in the future. Okay, so whatever is happening, going to happen in the future about that particular condition. Like I want to assess the levels of air pollutants and electric vehicles, or relationship between electric vehicles and levels of air pollutants. So what I will do today, I will start introduce the electric vehicles. I will have my intervention and I will follow it for next 3 months. So I will see whether the levels are reduced or the levels remain the same, or I will collect the data for every day. Every day I will calculate, or every day I will measure the air pollutants or levels of air pollutants like PM 2.5 particle, PM 10 particle level. Okay, I will measure the levels for next 3 months. So I will analyze after 3 months. That is a prospective study design. It attempt to establish the outcome of an event, or what is likely to happen. So what is likely to happen? What is probability that air pollution will go down after introduction of electric vehicle or after intervention of electric vehicle? So that is the future outcome. So it attempts to establish the outcome of an event, or what is likely to happen in the future. That becomes your prospective study design. So prospective study design, you are into present and you will collect the data of future. So from present, you will move to future. So data collection, you will start in the present. You will start data collection in the today. Maybe you will have some intervention, or you will have your study design, and you will collect the data of the future. Maybe you will have some period, that is time period. Okay, so that time period is T. For that particular time period T, you will collect the data and you will analyze the data in the future. That becomes your prospective study design. Prospective going towards future. From present, you are going towards future. That becomes your prospective study design. Examples of prospective study design: to establish the effects of a counseling service on extent of marital problems. Okay, so suppose today some agency or government is starting counseling services in relation to some marital problems. So after counseling, what is whether the problems are reducing or the problems are increasing, maybe after 6 months or after 1 year. So that is prospective study done in a prospective manner. You are in present and you will collect data for next 1 year, and after 1 year you will analyze the data. To determine the impact of random breath testing on the prevention of road accidents. So today government is introducing these breath testing devices, random breath testing devices on the road, especially at the nights, because those who are alcoholics, there are a possibility that they will create an accidents. Okay, so there will be road accidents because of consumption of alcohol. So breath testing devices will record whether the person has consumed alcohol or not, right? So if government is introducing this kind of program where for prevention of road accidents, they are introducing breath testing devices. Now government has introduced today, and government will follow it for next 3 months, or government will follow it for next 6 months or 1 year, and they will assess the data after 3 months or 6 months. That is a prospective manner. From present, you are moving towards future. That is a prospective study design. To find out the effect of parental involvement on the level of academic achievement of the children. So suppose a school or suppose a college or university, if they are involving their parents, like there are children who are studying in the school, and if the parents are involved for in their academic activities. So what is the level of academic achievements? Whether the level of academic achievements is increased or decreased, or academic achievements are increased or decreased after introduction of the word parental involvement. So parental involvement is the intervention that is taken or that is introduced by a school. So school is introducing intervention in the form of parental involvement for academic activities. Okay. After this, maybe the school will follow it for 1 year or for that particular academic year, and they will compare with the previous academic year and current academic year. Okay. So that kind of study, like data of the future is taken from present for next academic year, entire academic year, parents are involved in the activities of the students or activities of their kids, and the outcome is measured. Outcome is measured for future or after 1 year or after 6 months. That becomes a prospective study. To determine under field conditions the impact of maternal and child health services on the level of infant mortality. So government is introducing a program on maternal and child health services. Okay, so this is the government's program. So on the level of infant mortality, so they have a particular program, and under this program, they will see that how the mortality is reduced. So now this program is introduced today, and over a period of 1 year or over a period of 6 months, they will assess the data, or after 6 months, they will assess the data. After introduction of this intervention, they will have an intervention in the form of maternal and child health services, and they will assess the level of infant mortality, right? So that is a prospective study design. Retrospective prospective study design: focus on past trends in a phenomenon and study it into future. So basically retrospective prospective, the name itself suggests that retrospective means first you will collect the data of past, then you are into present, you will have your intervention, and then you will collect the data of future. Okay, means it involves both. First, the data of past is collected. Based on the data of past, intervention is introduced, and it is followed in the future. So it is a part of both retrospective as well as prospective study design. Means it involves data of past as well as data of future, right? So focus on past trends in a phenomenon and study it into future. Okay, so it will focus on what has happened in the past, and it will collect the data of future. Part of the data is collected retrospectively from the existing records before the intervention is introduced. Okay. And the study population is followed to ascertain the impact of intervention. Now, in my case, I want to assess the impact of electric vehicles. So what I will do before introduction of electric vehicles, first past 3 months, I will collect the data. So what were the levels of PM 2.5 particle or air pollutant for last 3 months? That I will collect every day based on the secondary source data. Secondary source data that is available on the website, that is available on the organizations or government registry. So that data I will take it for 3 months. Today I will introduce electric vehicles. After introduction of electric vehicles, I will collect data for next 3 months, right? And I will compare the difference for past 3 months with the data which is collected for next 3 months. That difference I will see, and that is a part of my retrospective prospective study design. So basically in retrospective prospective study design, what we do, we are in the present, we want to have some intervention. But before intervention, what we do, we go in the past, we collect a secondary data or recall data. Recall means if you are dealing with the population, if you are dealing with the people, okay, or human beings, then you have to ask them questions. They have to recollect the data of the past and they have to give the information. Or in my case, like I am just collecting a mechanical data or data that is given by the equipment. So that is secondary source data, which is already available. So what I will do before intervention of electric vehicle, I will go in the past. Go in the past means we'll collect the data of past for past 3 months. Okay. After collecting the data for the past 3 months, now today I will introduce the intervention. And after introduction of intervention, I will follow this situation for next 3 months. Every day I will check the levels of air pollutants, maybe levels of PM 2.5 particle, levels of PM 10 particle for next 3 months. And at the end of 3 months, I will analyze what was the situation before introduction of electric vehicles and what is the situation after introduction of electric vehicles. That becomes my retrospective prospective study design. So it focuses on the past trends in the phenomena and study it into future. So first the data of past is collected and it is the study is continued for a future data. Part of the data is collected retrospectively from the existing records before the intervention. So before intervention, you collect the data. Once you collect the data, then you will have your intervention, and then the study population is followed to ascertain the impact of intervention. So study population or situation or phenomenon is followed to ascertain the impact of intervention for that particular time period T. Okay.
So my query is most of the studies that we do, we review our literature before actually designing our study. So we collect some data which is already there in the existing literature. We summarize those findings and then we incorporate that to design our future study. So isn't in that way, most of our studies actually are retrospective prospective study design, no, sir? Because we are
No, like
using some findings.
if it is a, see, there are two parts. One part is study design and one part is your study design incorporating the data. Studying
Yes,
review of
sir.
literature will give you idea about what other investigators have done and what other investigators have not done. Review of literature will help you to find out gap in the literature. So gap in the
Yes, sir.
literature cannot be a retrospective study. You find like before start of any research problem, you should know which part of research problem should be focused, which part of research problem should be studied. Okay, you cannot consider it as a data of past, like review of literature cannot be a data of retrospective data. It is to find out what aspect of research problem you want to study or what aspect of your research design you want to study. Okay, which variable you want to study. Suppose there are 10 variables related to your research problem and other investigators have studied 8 variables extensively. So you need not have to focus on those 8 variables. You can exclude those 8 variables and you can just study 2 variables. So that is a function of research. That is a function of review of literature. But in case of
Okay.
retrospective prospective study design, you will have your design in such a way that data, whatever data which you are going to use for analytical
The
purpose, for
actual
analysis,
values.
for
Okay.
application of test of
That will.
significance, yeah,
Okay.
that
Okay, sir.
data, yeah, that data will be part of your analysis. You will use it
Oh,
in the analytical part. So examples, the retrospective prospective study design, effect of random bit testing on road accidents. So now government wants to initiate this program, random bit testing, to reduce the road accidents. So what they will do, they will assess data of past 1 year or past 2 years. Based on that, they will have idea like per week how many accidents happen because of because they are not using random bit testing devices, especially in the night, right? So and after introduction, now they are in the present. So today they will introduce this program and they will follow it for next 1 year. So in next year, 1 year, per week how many accidents are happening. Suppose before introduction of this random bit testing for past 1 year, average number of accidents which happened in a week time are 10. And after introduction of this random bit testing, the if it is reduced to 5, means there is 50% reduction because of this program intervention. So government has intervention in the form of introduction of random bit testing. So what they did, they collected data of past 1 year. Past 1 year, how many accidents happened per week? And now they are introducing these random bit testing devices. For next 1 year, they will follow up, and after 1 year, they will analyze what is the reduction, whether there's a reduction in the number of accidents or the accidents have increased. Okay, so that is your retrospective prospective study design. Impact of incentives on the productivity of employees of an organization. So what organization will do? Organization will see the productivity of employee for last 1 year, okay, for last one financial year or last one academic year. And now they have a program to introduce incentives for particular activity, incentives for particular academic activities. So organization will have incentives and they will see whether productivity means they will have a number of variables. Different organizations have their different variables to see the productivity. Okay, so they will see whether productivity has increased or it has decreased after introduction of program. What is a program? Impact of incentives means incentives is a program. Giving incentives for particular work is a program that is introduced by organization, and after this introduction of program, what was the productivity, whether it has increased or decreased. Means retrospective data is compared with the prospective data. The impact of maternal and child health services on the infant mortality. So infant mortality before introduction of this maternal and child health services, and infant mortality after introduction of maternal and child health services. So data of past 1 year and data of future 1 year will be compared, right? And that becomes your retrospective prospective study design. The effect of an advertisement on the sale of the product. The sale of the product for last 1 year. What was the sale of the product for last 1 year, right? That data will be taken by company, and now they are advertising. They are putting money in advertisement, and after advertisement, what is the amount of sale for next 1 year? So amount of sale before advertisement, 1 year before advertisement, and 1 year after advertisement. So what is effect? Whether the after advertisement sale is increased or it is decreased. All these studies, they fall under the category of retrospective prospective study design. Okay, so to conclude, what we have three types of study design here. First is retrospective study design A, prospective study design B, and C is retrospective prospective study design. In study design A, that is retrospective study design, what we are doing, we are in the present and we are going back in the future, back in the past. Okay, and we are collecting a data of past. That becomes retrospective study design, right? In prospective study design, we are in present and we are moving towards future. So today we are introducing intervention and we are going in the future for the collection of data, right? So that is prospective study design. And retrospective prospective study design is that we are in the present. Before intervention, before introduction of intervention, I will go in the past, I will collect the data of the past, and I will have intervention today. Okay, after intervention, I will have time period T, and during that time period T, I will collect the data and data in the future, right? And I will analyze the data, or I will compare the data of future and past, right? So retrospective is from present to past, that is retrospective study design. From present to future, that is prospective study design. From present to past before intervention, and then from present to future after intervention, that becomes your retrospective prospective study design. We discussed two classification based on number of contacts with the study population, reference period of the study, and now we will discuss nature based on the nature of investigation. So based on the nature of investigation, we have experimental study design, non-experimental study design, and semi-experimental, or they are also called as quasi-experimental designs. Again, under experimental study design, we have the after only experimental study design, before and after experimental study design, control group design, double control group design, comparative design, match controlled experimental design, and placebo design. Okay, so we will discuss this group today. Now coming to experimental and non-experimental study design. Like in experimental and non-experimental study design, basically we study the cause and effect relationship. We have a cause and we study its effect. So in experimental and non-experimental study design, basically we study the cause and effect relationship. So experimental study design means what? You are moving from cause towards effect. That is experimental study design. And when you are moving from effect to cause, that is your non-experimental study design. So in experimental study design, you have a cause as intervention. Your intervention is your cause. Okay. So cause is intervention and you will see the effect of that particular intervention. Means you are doing experiment. Why it is called as experimental study design? Because you have an experiment, you have an intervention, you have an active intervention. When you have active intervention, that is called as experimental study design. When you do not have experimental experiment, or when you do not have active intervention, that becomes your non-experimental study design. Means already effect is present and you are trying to find out the causes. So from effect to cause, when you move, it is called as non-experimental study design. Already effect has happened, already effect is present, and you are moving from effect to cause to explore the causes. You want to find out what are the causes, what are underlying causes for that particular effect. Then it is called as non-experimental study design. Now I will explain with the example. My example is on electric vehicles and the levels of air pollutants. Now, electric vehicle is the cause. Electric vehicle is intervention. So when I want to introduce electric vehicle, that is a cause and effect relationship. I am introducing a cause to see the effect in the form of levels of air pollutants. So that is experimental study design. I have an active intervention in the form of introduction of electric vehicles. So today I am doing this intervention. I am introducing a cause. I am introducing electric vehicles. I am introducing intervention in the form of electric vehicles to see the levels of air pollutants, whether they are going down or they are increasing. Means I am checking the outcome. After introduction of electric vehicles, what will be the outcome after 3 months? What will be the outcome after 1 year? Whether the levels of air pollutants will go down or it will increase. Means I have a cause, I have an intervention, and that after that intervention is a cause. Its outcome is effect. Effect is in the on air pollutants. So air pollutants will go down. So I have active intervention here. Means intervention is electric vehicle and the effect is level reduction in the levels of air pollutants or change in the levels of air pollutants. That is cause and effect relationship. The second part is non-experimental study design. Effect is already present. Suppose I go to some area. Suppose I go to Northeast and I find that the levels of air pollutants. I have equipment to check the levels of air pollutants or PM 2.5 particle. I have gone for some other purpose, but I find that there is no air pollution. I just check the levels and levels are 10 cubic millimeter, 5 cubic millimeter, or almost nil. Okay. So I'm wondering why this effect is present. Effect is already happened. What is happened? The levels of air pollutants is almost zero. Level of air pollutant is there is no air pollution. So why there is no air pollution in that particular area? Effect has happened. So I will go back and I will try to find out the causes. What could be the causes? Means I will try to find out the number of vehicles which are present there. Maybe the vehicles are less or the industries are less or some other factors which are contributory to these air pollutants. They are less in that particular area. So effect is already present and I am trying to find out the cause. Okay. One more example, real life example. Suppose I have a study population who are smokers or tobacco chewers. Maybe I will follow them for next 10 years. Suppose I have a population of 100. Out of 100, how many develop cancer? Means chewing tobacco is a cause. Tobacco is a cause. Because of that cause, how many people develop cancer? That is cause and effect relationship. That is active intervention or there is experimental study. But already people who are suffering from cancer, I have a population 100 people who are already suffered from cancer. So I will go back. Go back means I will take their history and I will find out why this cancer has developed. Okay, means were they tobacco chewers, were they smokers, or were they working in some chemical industry, or there might be a number of reasons for development of cancer. So I will try to explore the causes of cancer. Means effect is already present. So in non-experimental study design, what I have a study population who have already suffering from cancer. I will go back in the past. I will take their history and I will try to find out what was the causes for development of cancer. I will try to explore. Means already effect is present, and that is non-experimental study design. But if I have a study population of 100 who is chewing tobacco or who is smokers, and for next 5 years, I will follow up them and I will see the outcome or impact in the form of development of cancer. How many develop cancer? Out of 100, how many develop cancer? So I can claim that suppose out of 100, 50 develop cancer or 60 develop cancer or 70 develop cancer. Then I can claim that 50% contribution or 70% contribution is because of tobacco. So that I can claim, and that is experimental study design. Means there is active intervention. Okay, so similar to my electric vehicle or maybe this tobacco use and cancer, right? So experimental means you are going from cause to effect. That is experimental study design. You have intervention and you are seeing the outcome of that intervention. That is cause and effect relationship, and that is experimental study design. And in non-experimental study design is passive design. There is no active intervention. Effect has already happened. So you are going from effect towards cause. You try to explore the causes in case of non-experimental study design. Everybody got it? The concept of experimental and non-experimental study design. Experimental study design, you remember that there is active intervention. Non-experimental study design, there is no active intervention. Okay, so that is the difference. Now coming to first part, that is experimental study designs. We will discuss today about these experimental study designs. The after only experimental study design, before and after experimental study design, control group design, double control group design, comparative design, match control experimental design, and placebo design. So under experimental, we have these categories, that is these 6-7 categories. We will discuss one by one. Now coming to the first study design, that is after only experimental design. Now in after experimental design is what? After only means after introduction, you will collect the data. So what is written here? Information on baseline, that is pre-test or before observation, is usually constructed on the basis of respondents' recall of the situation before the intervention or from information available in the existing records, that is secondary sources. Okay, so what is the meaning of this? Suppose I want to conduct my study as after only experimental design. What I will do today, I want to introduce my intervention of electric vehicles. I will go in the past. I will collect the data of past from the secondary sources, maybe from the websites or maybe from the records which are available with the government. So I will collect the data for last 3 months, past data, that is from secondary sources. And today I am having my intervention. So previous study I have not done in experimental way. There was no intervention. There was no intervention of electric petrol vehicles or diesel vehicles. Today I want to have intervention of electric vehicles, but I have collected past data for comparison purpose. Means pre-test data or baseline data. Baseline means what is level of air pollutants today. Suppose average level of air pollutant for last 3 months is 150 cubic millimeter. That is my average level. How I arrived on that average level based on past data which is taken from the secondary sources. Okay, and then today I will have intervention, and for next 3 months I will record the data of air pollutants after introduction of electric vehicles, and then I will have average. Suppose from 150 it has reduced to 50 cubic millimeter. So there is drastic reduction in the levels of air pollutants after introduction of these electric vehicles. Okay, after only experimental design means after you are collecting the data of past by a secondary method. It is a secondary source data, and your intervention is at present, means you are from moving from present towards future, and the retrospective data is collected from the secondary sources. You have not actively done it. Actively done it means there is other way. What I can do from today, I can study the for next 3 months, I can study the levels of air pollutants for petrol and diesel vehicles. After 3 months, like after collecting the data for petrol and diesel vehicles for air pollutants for 3 months, then I will introduce my intervention of electric vehicles after 3 months. That becomes my pre-test post-test data. Okay, before and after experimental design. But after only experimental design means before data is constructed. The word is constructed means it is constructed based on the secondary source information. Based, I have taken data from some information that is available on the website or secondary sources. Or when you are dealing with the human population, it is a recall of the situation. Suppose you are dealing with a population like Bhopal gas tragedy, they will recall whatever they will recall about that particular situation. You will collect the data when you are dealing with the study population. That becomes my after only experimental study design. Means I will have intervention. I will follow with that intervention for next few months, and for comparison, I will collect the data of the past based on the secondary source data or based on the recall of that particular situation of the respondents. Okay, that is called as after only experimental study design. So if you see here, we have a study population and we have intervention for time period T. Okay, so we are in the present, but what we are doing before or pre-observation or baseline construct. So baseline data or pre-test data or before observation data is taken from what? From existing records or recall of the respondents, whatever they recall, whatever they remember about that particular situation or phenomena when you are dealing with the human participants, right? So that data is collected. Now you have intervention for time period T, and post data is collected. Post data means after intervention data is collected. So you have a data of baseline. Baseline, you know that the levels of air pollutants are 150 cubic millimeter. Today I will have my intervention in the form of electric vehicles. After intervention, I will follow for next 3 months and I will collect the data after 3 months about the levels of air pollutants. So I will compare this data after 3 months and baseline data. So I will see the baseline data, before data, pre-observation data is 150 cubic millimeter, and after 3 months the data is 50 cubic millimeter, right? And I will compare like there is whether there is statistically significant reduction in the levels of air pollutants or not. So I will arrive at some conclusion, right? So after only experimental study design means there is experiment, there is active intervention, but that active intervention is for the future, for prospective data. The data of past is collected based on the respondents recall or based on the existing records. That is called as after only experimental study design, right? So we have study population, intervention for time period T, but before intervention, we collect the data of baseline. We create the data of baseline. We construct the data of baseline based on the recall of respondents or based on the existing records. Any doubt in this, anyone?
Sir, it is same as retrospective prospective study.
See, the studies will overlap. I will go back to the classification. Your study might fall into all the categories. Your study may be before and after study, prospective study, and experimental study. Okay, or your study may be cross-sectional study, retrospective study, and non-experimental study. So one study will fall into different categories. These are different categories. Okay, so your study may be cross-sectional study. Suppose I want to collect data of on electric vehicles or I want to collect data for air pollutants. What is the level of air pollutants for today? So I will take a cross section. Suppose I find it at 120 cubic millimeter. That is cross-sectional study. Okay, so I can use it as a I can do it in a maybe prospective manner, retrospective manner, experimental manner, non-experimental manner, semi-experimental manner. So one study, whenever you have your study design, that study design will fall into multiple categories. So it cannot be restricted to one particular category. Your study design cannot be only experimental. It will be experimental and prospective. It will be experimental and retrospective and prospective, or it will be experimental and longitudinal, or it will be experimental and before and after study. So it will fall into multiple categories rather than it sticking to one particular category. So always remember, whenever you are giving your classification, whenever you are talking about your study design, you have to talk in terms of all these of classification. So why it is classified? Because it is your study will fall into most of these classifications, into almost all the types of classifications, right? Yeah, before and after. The first is after only experimental study design. Second is before and after experimental study design. Now in after only experimental study design, what we are doing, pre-test data or baseline data is constructed. It is constructed how? Based on the existing records or recall of the respondents. Means we are not actively collecting the data of past or before data or pre-test data or before intervention data. In case of before and after experimental design, actively before data, pre-test data is collected. Okay, it is not constructed based on the secondary source data. It is collected. Suppose I want to check or assess the impact of electric vehicles on air pollutants. What I will plan? I will plan a study of 3 months, 6 months. In first 3 months, I will check the levels of air pollutants because of petrol and diesel vehicles. Okay, in a particular area. After 3 months, I will introduce the electric vehicles in that area and I will assess it for next 3 months. Means before data I have actively collected. I means as an investigator, I have collected data and that is a part of my experimental study design. There is active intervention. There was intervention of petrol and diesel vehicle. I collected data for 3 months. Then I introduced my experimental group. That experimental group is my electric vehicle. I want to assess the impact of electric vehicles. So I introduced it and for next 3 months, I will collect the data. Okay, means I have data of pre-test or before data that is actively taken, actively collected. Okay, and it is a part of experimental study design. It was not a passive recording. It was not a secondary source data. It is not based on the some records. It is not based on the recall of the respondents, but it is actively taken. So pre-test data is actively taken by your active intervention. There was active intervention of petrol and diesel vehicles. Okay, for 3 months. And after 3 months, I am introducing electric vehicle, active intervention of my experimental group to assess the impact of electric vehicles. And I will again follow it for 3 months. So that is after experimental study design. So I have to both the arms. Pre-test data is not constructed, but it is actively collected. Okay. In after only experimental design, the baseline data or pre-test data is taken from secondary sources. It is not actively collected. It is constructed. But in before and after experimental design, the pre-test data, the baseline data, the before data, it is actively collected. So active collection of your data is a part of your experimental or it is a part of intervention. There was an active intervention of petrol and diesel vehicles. Okay. And then for next 3 months, there is active intervention of electric vehicles. So I have a data of pre-test, pre-observation data or baseline data that is because of active intervention and not because of passive recording. Okay, it is not a passive data, it is an active data. That is difference between after experimental study design and before and after experimental study design. You can also call it as pre-test, post-test experimental study design. Pre-test, post-test experimental study design. Your data of pre-test or pre-intervention and post-intervention experimental study design. You can name in any way. Pre-intervention, post-intervention experimental study design, before and after experimental study design, pre-test, post-test experimental study design. It is one and same thing. See, in after only experimental design, what I did now today, I want to start with my intervention. Which intervention? Intervention of electric vehicles. So what I will do before that intervention, I will collect data of baseline. How I will collect that data? From the records, existing records which are available on the website. I will go to the website of maybe whatever website which is focusing, or I will collect the data from government registry about PM 2.5 particle for last 3 months. Okay, so I will have that record for last 3 months, pre-test data, passive data, secondary source data. It is not active data. It is a passive data. Someone else has collected data. As an investigator, I am not collecting data. I am not having any active intervention. What is experimental study design? Experimental study design means when you have active intervention, that is called as experimental study design. Non-experimental study design is what? When there is passive intervention, there is no intervention. Effect is already happened. Okay, so PM2 level is already calculated by someone. There was already effect happened. That is pre-test data you are constructing. Okay, you are not having any active intervention. That is after only experimental study design. And before and after experimental study design, you have active intervention for pre-test data and you have an active intervention for post-test data. Now, what I want to assess? I want to assess the impact of electric vehicles. But before studying the impact of electric vehicles, what I will assess? First, I will assess the impact of petrol and diesel vehicles for 3 months. I will design this study in such a way that I will take 6 months time rather than 3 months time. For first 3 months, I will have active intervention of petrol and diesel vehicles and I will collect the data of PM 2.5 particle for next 3 months with petrol and diesel vehicle intervention. Okay, I will take out the average. After 3 months, I will introduce electric vehicles. And after introduction of electric vehicles, again, I will follow it for next 3 months and I will collect the data for electric vehicles. That becomes my before and after experimental study design. Means both arms, before arm as well as after arm, pre-test arm, post-test arm, pre-intervention arm, post-intervention arm. Both are active arm, both are active interventions. That is before and after experimental study design. The before and after design overcomes the problem of retrospectively constructing the before observation. So in after only experimental design, what we did, we retrospectively constructed the before observation by establishing it before the intervention is introduced. So what we did in after only experimental design, we created the baseline data based on the previous records or based on the respondents recall. Okay. In before and after study design, we are not doing that way. Does not enable one to conclude that any change in whole or in part can be attributed to the program intervention. This is a drawback. What is happening here? I will just give you example about this electric vehicle and petrol and diesel vehicle. Now I have designed a study in such a way that it is for 6 months period. For first 3 months, I collected data on petrol and diesel vehicles about PM 2.5 particles. After 3 months, I introduced electric vehicles. I studied it for 3 more months and I collected data for next 3 months. So total, I have data for 6 months. First 3 months about petrol and diesel vehicles and next 3 months about electric vehicles. Now in this, I am not considering the extraneous variables. Suppose I am conducting this experiment in the Navi Mumbai region, particular nodes of Navi Mumbai region, and nearby that node, if there are factories, if there are industries which are eliminating PM 2.5 particle. So I am not considering this part into my before and after experimental study design. So in before and after experimental study design, what I am measuring? I am measuring the data for past. Actively, I am measuring the data for before intervention, pre-test data, pre-intervention data. Okay, and after intervention, again, I am measuring, but I am not considering the effect of extraneous variables on my dependent variables or effect of my extraneous variables, that is industries, on air pollutants. How much air pollutants are released by industries? How much air pollutants are eliminated by industries? That part I am not considering. I am just checking pre-test data of petrol and diesel vehicle and post-test data of electric vehicles. That's it. But there is possibility that nearby industries might be contributing some levels of air pollutants, this eliminating some levels. That part I am not considering. I am also not considering random or chance variable. There might be possibility that because of faulty instrument, there might be incidences that one for particular period of time the instrument is faulty and I have not collected the right data. So all those parts I am not considering. I am just considering pre-test data and post-test data, pre-intervention data and post-intervention data. That is a drawback which is associated with before and after experimental study design. Okay, means what you are not considering, you are not trying to eliminate extraneous variables in your study. In fact, you are introducing that error in your study by keeping the extraneous variables and random and chance variables in your study. So that is a drawback of before and after experimental study design. So rather than taking this kind of study design, go for a control study design that will take care of your extraneous variables and random and chance variables. Okay. So why we keep control group? You must have done these kind of studies. You must have taken experimental group and control group. Why do we take control group? To reduce the impact of extraneous variables, to eliminate the impact of extraneous variables, to reduce the impact or to eliminate the impact of random and chance variables, right? So this kind of studies won't be helpful. If you are doing experimental study design, try to eliminate all these variables. Otherwise, whatever impact you are getting, what is it, outcome variable impact you are getting, that is not a true impact of your independent variable. That is impact of your independent variable plus impact of extraneous variables plus impact of random and chance variable. So you have so many impact on your dependent variables. Okay, so it is not pure study. You want to assess pure impact of independent variable on dependent variable, but you have additional factors like random variable, chance variables, or extraneous variables that are not taken care in this before and after experimental study design. And that is the drawback which is associated with before and after experimental study design. Now, if you see before and after experimental study design, this is a baseline data. Okay, you have intervention here and you will collect the data after intervention. This may be changed. There are two possibilities. Initially, the baseline data may be on a higher side. Like in my example, baseline data means suppose petrol and diesel vehicles. If I introduce petrol and diesel vehicle for 3 months, in these 3 months, the baseline data, pre-test data or pre-intervention data, the levels may be high. Okay, this is first situation is applicable for my case. After intervention, the levels are going down after intervention of electric vehicles. Here I am introducing electric vehicles, and after introduction of electric vehicles, the levels are going down. So that is a post-state observation. This is first situation. Some other may have some experiments where baseline data is on lower side. Okay, suppose somebody is seeing the effect of some drug on fever. Okay, maybe initially fever is low and it is again in the first category. Okay, so you have some intervention where the levels are low and after intervention the levels are increasing. Suppose I am measuring the levels at the baseline of electric and I'm reversing my study. Suppose I have an area where already people are using electric vehicles. I have a region where already all the people are using electric vehicles. So suppose I collect the data of baseline, I collect the data of pre-test, that the levels will be low. The levels of air pollutants will be low. So second situation is that your baseline data is low, pre-test data is low, levels of pre-test data are low. Now what I will do, I will reverse my experiment and I will introduce petrol and diesel vehicles here. So the levels will increase and post-test, these are the post-test observation. So I can comment that after introduction of petrol and diesel vehicles, the levels are increasing. So this is second way of seeing the before and after experimental study design. So here what you are getting change as a whole and not you are seeing the impact of random variables, chance variables and extraneous variables. That is drawback which is associated with before and after experimental study design. So no doubt we will move to next study design, that is control group design. So control group design is basically to take care of the drawbacks which are associated with your before and after experimental study design. What was drawback that was associated with before and after experimental study design? Here you cannot control the effect of extraneous variables or random and chance variables. Now in control group design, how you can control the effect? Here you have two groups. Here you have two groups means you have an experimental group and you have a control group also. Okay, so researchers select two population group instead of one. One is control group and second is experimental group. Okay, so here you can control the impact of your random variables, chance variables, or you can control the impact of your extraneous variables also. So here what is situation? You have a study population. You have a first group where you have intervention, that is active intervention in the form of your experiment, whatever experiment or whatever is your research problem, that is your experiment or that is your active intervention, and you will assess the study population or you will assess the situation for time period T and you will collect the data. You will have one more group as a control group, and in that control group you will see the control means how much control is achieved. Control group is why you will have similar impact. What impact? You will have similar impact of extraneous variables or random and chance variables on control group also. Okay, now what is my aim? I want to assess the impact of electric vehicles on air pollutants. So what is my experimental group? My experimental group is electric vehicle. Now in one node, I will introduce electric vehicles and I will assess the impact. But which node I will select? I will select two nodes in such a way that one node will act as my experimental node and second node will act as my control node. Okay, but what should be the situation? That experimental node and control node should have similar exposure of industrial air pollutants. Okay, means both are exposed to the same way, similar way. Like both the nodes should be of at the same distance from that industries. So same levels of air pollutants are eliminated in that area. So I can design maybe in the form of electric vehicle and I can take one more vehicle as a CNG vehicle. So I can design this study as I can collect the data of past, or I can collect the data of baseline. I can create the data of baseline. Suppose the data of baseline for last 3 months for both the nodes is 150 cubic millimeter or nearby that. 150 cubic millimeter for one node, 140 cubic millimeter for other node. Then I can select my node where first node where I will introduce electric vehicles. That electric vehicles will have similar impact. Okay. And then I will select the second node where I will introduce CNG vehicles or hydrogen vehicles. But that node will also have similar impact. Means known control. I should have some known control. If I do not have data of CNG vehicle, means that is a standard control. We call it as a standard control. Standard control means it is a standard thing. The data for that particular thing is available. I will give you a simple example. Suppose there is one company, that company has manufactured new drug, or that company has manufactured new medicine. That medicine is used for fever. So they want to assess the impact of their medicine in reducing the fever. Okay, high fever. Now there are standard drugs or medicines which are already available in the market. So they will compare with the standard medicines which are available already available in the market. That data for that standard medicines are already available. Means the standard medicine will act as a control group because the data for that particular group is available. Now the CNG vehicles are there since last 15-20 years, or at least for 10 years in India. So you can have data, or you must be having data for CNG vehicles. How much reduction, or somebody must have done the study on CNG vehicles. So you have a standard comparator. What I need here, I need a standard comparator. So what I did here, I selected two nodes which have similar exposure to the industries. Okay, means industry has similar exposure of those air pollutants to those two nodes, right? Then first node I selected as experimental node, and second node as a control node. First node, where that is experimental node, I will introduce electric vehicles, and second node I will have intervention in the form of CNG vehicles, because I have a comparator data. Standard control is CNG vehicle because these are running from last 10 years, and electric vehicle is a new thing. It is introduced for this year, right? So electric vehicle I will assess for next 3 years, and CNG data already the data I have. So I will just compare with that CNG data, right? Means I have a group, control group. Why control group? To reduce the impact of random variables, to reduce the impact of extraneous variables. How that impact is reduced? Now I have two nodes. In first node electric vehicles, and second node I have CNG vehicles. The industries will impact electric vehicle also and CNG vehicles in the same manner, right? Means if you subtract it, if you subtract the total impact of electric vehicles minus the total impact of CNG vehicles, you will get your impact. Means what you will have, the impact of, if you see here, impact of program intervention. What is my program intervention? My electric vehicle is a program intervention, plus minus impact of extraneous variables. What are the extraneous variables? Variables means the pollutants which are released by industries. And third chance is third plus minus impact of chance variables. Chance means what? There is possibility that for during these 3 months the instrument is faulty for 4 days, but I am using same instrument at both the places. Every day I'm using same instrument. These places are near in the nearby vicinity. I'm using same instrument. Every day same instrument is used at both the places. So if I'm using same instrument, if I am getting faulty record for node A or experimental node, I will also get faulty record, same faulty record for control group. Means I have control what? I have a control chance variable, random variable. Okay, either you can delete it if you come to know that instrument was faulty for those particular day. If you do not come to know, even that will not affect. Why that will not affect? Because you have similar impact on experimental group as well as control group. Means that instrument which I used, I recorded the PM 2.5 particle level with that faulty instrument from experimental as well as control node, from electric vehicle as well as CNG node. So there will be same level of error that is introduced because of this random or chance variable. Okay, once you subtract it, that everything will be subtracted and you will get pure impact of your intervention. So what is here? Impact of program intervention. That is, in my case, it is impact of electric vehicles plus minus impact of extraneous variables. That is impact of industries plus minus impact of chance variables. That instrument was faulty on few days. Okay. Minus impact of extraneous variables in control group. So whatever is the impact of extraneous variables, how will you calculate the impact of extraneous variables in control group? Since you are using CNG vehicles for past 10 years, you know how much is the impact of CNG vehicles on the air pollutants, how much reduction is caused by CNG vehicles. So you know that impact. Impact is 10% or impact is 20%. So that impact you need not have to minus. You have to minus only from control group. Suppose you know the because of CNG vehicles, there is impact of 30% reduction, 40% reduction. So you need not have to consider 40%. Suppose if you see total amount of reduction about maybe 60% or 80%. So you know what is the impact of this particular CNG factor. It is 40%. Additional 20% is because of faulty instrument or because of industries which are eliminating PM 2.5 particle. So here what is control group acting as? It is acting as a standard control because values related to that group are available with you. You do not have values for electric vehicles, but you have values for CNG vehicles. You know how much is the impact of CNG vehicles. Okay, so that impact you can keep aside. Right? Suppose that example just now I gave that 80 cubic millimeter is a reduction up to reduction, but you know that 40 cubic millimeter is contributed by your CNG vehicle in control group. So what remains 40 cubic millimeter? That 40 cubic millimeter you can minus it from electric vehicle group. So for electric vehicle, if the impact is 60 cubic millimeter, 60 minus 40 cubic millimeter, in the end you will get impact as a 20 cubic millimeter. So total impact, actual impact or actual impact of independent variable and dependent variable is 20 cubic millimeter. Actual impact of electric vehicles on air pollutant is 20 cubic millimeter. From 150 cubic millimeter, it has reduced to 20 cubic millimeter. So you can find out the percentage, how much percentage of reduction has happened because of electric vehicles. And because you are aware about CNG vehicles, the standard control, standard comparator. Okay, so you have a standard control available with you. So impact of electric vehicle plus impact of extraneous vehicle plus impact of chance variable minus impact of extraneous variables in control group plus impact of chance variables in control group. That will give me pure impact of electric vehicles on air pollutants. So here what we are doing in control group, we are taking the values of only extraneous variable and chance variable because we are already aware the values of control group, standard comparator. That values are already known. That values are already studied by some other people. That values you can take it from review of literature, or from literature you can collect the value, or you can collect those value from secondary source data.
So
Yeah.
either taking data from other studies or the already available data, we can also collect the data for control group. No?
You can collect the
Without
data.
giving intervention.
Yes, you can collect the data.
Without
You
giving
can.
intervention will be okay, or is it ethical? Or
No, you have to give intervention. No, this is experimental study design. Without intervention, it cannot be experimental study design. When you want to have experimental study design, you have to have active intervention. That is mandatory. When do you
no,
call it as experiment?
for control group.
Even for control group, no, there is active intervention. My CNG vehicles were all running in that particular area. Only thing is that I know the value for CNG vehicles. Control group design means it is a standard comparator. When you have a standard control group that is available, information about a standard group is available, then only you can use it standard control group design. Okay, or control group design. If you do not have information, then you have to add one more group. To suppose I do not have value of CNG vehicles. So there is no use of adding the CNG vehicle. Then I can have experimental group as a electric vehicle, and I can keep petrol and diesel vehicle as a other group. So that will be comparative study. Only one arm is experimental arm. Other arm, we already aware of the data, right? So we need not have to have two arms. Rather, we are wasting the money because already that values are available for petrol and diesel vehicle. Okay, when it is already proven, when already the data is available, if you are again rechecking the data by keeping a parallel arm or control arm for the value which you are aware, then it is a wastage of resources or wastage of, you can see, finances also.
Sir, if the data is not available for same age group or the same condition, so
Then you have to collect the data. If the data is not available, then you have to collect the data for that arm.
Okay.
Can you elaborate your study? Like, I am not getting what you are asking exactly. What is your research problem? You must be having some research problem in mind, so you are asking, right?
Yes, sir. But basically, sir, this question is because like we have done the previous study in our master, so we are also taking control group. So we are giving a standard treatment for control group, and for the intervention for the experimental group, we are giving a particular intervention.
Yes,
So
standard. Why you are using standard? Because it is proven fact.
yes.
So what is your doubt actually? Can you give some example, or if you have, you can remember some example,
Sir,
then
I
it is better to
understood now.
understand.
I
Achha, you understood?
Yeah.
I'm taking Jatamansi extract in autistic children. Right? So, if I have data available on Jatamansi but not on extract formulation, then will it come under the control group? I have data on Jatamansi. There are number
Jatamansi on
Jatamansi is the drug.
no Jatamansi on epileptic patients,
Autistic children.
autistic children. Okay.
So if I have data available on Jatamansi but not on extract, the formulation.
Different formulation. It has multiple formulation.
Same is an extract. So I don't have any data on extract. Will it come under the control group or not?
No, but data is not available. No, it cannot be a standard comparator. See, it may be in the form. Does it have different action if it is used as a powder or some other format? The actions are different. Suppose if it is used as a powder or if it is used as a paste, is there any a difference in the action if it is used as powder and paste?
If it is there,
then you have to no, you cannot control. You cannot be a control group. It cannot be a standard comparator. Then it will be your experimental arm only. You can add that as that you can study as an experimental group. You should have a standard comparator because you are not aware about this. The data is not available or it is not used as a standard drug for that particular condition. So it is not a standard comparator. What is, in simple words, you require a standard comparator. Any other drug which is used in autistic children, a standard drug which is used in autistic children, if your drug is not used, if you are introducing it for the first time, if it is not used by many investigators and you want to assess its impacts on autistic children, so there must be some other drug which is taken by these autistic kids. Okay, so that drug you can keep as a control group. But different formulations, you can have different experimental groups. Formulation A, formulation B, that is a part of your experimental group. So formulation A is your experimental group 1, formulation B is your experimental group 2, formulation 3 is your experimental group 3. Okay, so different formulations will be different variables that you want to assess the impact of different formulations against your comparator. Okay, comparator means control group will be separate, but experimental group will have three experimental group. Experimental group 1, experimental group 2, and experimental group 3. Double control design. Now we just discussed about control design in which we have experimental group and we have a control group. Control group is taken as a standard comparator or standard control group so that it will control or it will eliminate or it will reduce the impact of extraneous variables and random and chance variables. Now, why we want a double control design? Although the control design helps you to quantify the impact that can be attributed to extraneous variables, it does not separate out other effects that may be due to research instrument, such as reactive effect or maturation effect or regression effect or placebo effects. Now, apart from these effects, we have discussed all these effects. Okay, we have discussed what is reactive effect. Especially these effects are applicable when you are dealing with human population. Okay, when you are giving questionnaire to a human population, they will have a reactive effect. Reactive effect means because they are educated. Repeatedly, you are exposing to same questionnaires because they are educated. They will have either reactive effect or they will have regression effect. Or if you're working on kids or if you're working on a group of population who are children, so they are growing. Maybe you started your experiment when the kids of 5 years of age and you are assessing them for next 5 years. So after 5 years, they will be of 10 years. So there will be level difference in the levels of maybe intellectual capacity or understanding capacity or all the parameters, physical parameters, mental parameters, all the parameters will change. They are maturing. So when you want to control such kind of impact, you should have a double control design. Okay, double control design will take care of all these possible effects: reactive effect, maturation effect, regression effect, placebo effect. This is essential when you have possibility of such effects, when you are dealing with the human population, when you have a study which is based on a questionnaire, right? Where you are dealing with the study population, you are asking them question, you are collecting the data, you will have some intervention for a longer period of time where study population is maturing. Suppose 30 years person is matured to 35 years. It may not create much difference. But 5 years child, when that child grows to 10 years of age, there will be drastic difference in all variables. You take any variables, there will be difference. Okay, so when you have such kind of population, you use double control design. Okay, so when do you use control design? When you want to control effect of extraneous variables, random variables, and chance variables. And when do you use double control design? Apart from controlling extraneous variables, random variables, chance variables, when you want to control the impact of reactive effect, regression effect, maturation effect, or placebo effect, then you use double control design. Okay. So in control design, it helps you to quantify the impact that can be attributed to extraneous variables, but it does not separate out the effect that may be due to research instrument. Research instrument means your questionnaire is your research instrument, such as reactive effect or maturation effect, regression effect, placebo effect. When you need to identify and separate out this effect, a double control design is required. Okay, so in double control design, what we have an experimental group, we have a control group 1, and we have a control group 2. So control group 2 will help you to what? Help you to reduce the reactive effect, help you to reduce the maturation effect, help you to reduce the regression effect. Suppose you have one study on kids who are of 5 years of age, and that study you want to do it for next 5 years. Then what you can have, it is experimental design. You have your intervention. You are doing that intervention in the kids or children. Okay. Suppose you have a population of 100 in experimental group. So you will have your intervention. You will have a standard comparator, that is control group 1, that will take care of your extraneous and chance variables. Okay, means standard comparator, that is group 2, again 100 kids. Now, after 5 years, those kids will be of 10 years of age. So at this point of time, you should have one group that is of 10 years of age. So you have experimental group that is 5 years of age, control group 1 that is 5 years of age. You are assessing the impact of your intervention in experimental group. You are assessing the impact of standard control, or you are controlling the extraneous and chance variables in control group 1. But you have a control group 2, which is of 10 years of age, that is going to mature after this population, the population which is of 5 years of age, that will mature after 5 years. That will be 10 years of age. To control the effect, maturation effect, now you have one more group that is added, and that is control group 2, which is of 10 years of age. Got it? So you will assess the impact on experimental group, which is 5 years of age, control group, standard control, standard drug, or standard comparator, that is 5 years of age. And again, you have one group that is 10 years of age. That is control group 2. Control group 2 here, what is use of this control group 2? That is helping that is helping to reduce the impact of maturation effect. Here I have taken example of kids, growing kids, children. Okay, 5 years, after 5 years you want to assess the impact, but after 5 years they will be of 10 years of age. So currently you have one group that is 5 years of age, second group that is 5 years of age, and third group that is 10 years of age, because you want to assess what happens at the 10 years of age. What variables are changing at the 10 years of age? What is the difference in the levels of variables at 5 years of age and 10 years of age? Okay, means maturation effect here you are controlling. There might be other situation or other study where you want to have to control reactive effect. There might be some other study where you have to control regression effect or placebo effect. Okay, so you have to understand what kind of impact or what kind of effect is associated with your study, whether it is extraneous, whether it is random, chance variable, whether it is reactive effect, placebo effect, maturation effect, regression effect, that you have to identify what kind of effect is associated with your study. And research instrument means, now I am using one research instrument, that is measuring PM 2.5 particle, that is research instrument. If you have a study that is based on questionnaire is your research instrument. So whatever instrument means, it is the method, whatever you are using for collection of data, that becomes your research tool or research instrument. So your questionnaire is also research instrument. Your case history is research instrument. When you are asking questions, that is research instrument. Interview is research instrument. Narration is research instrument. Okay, so that all are your research instruments. So if you have new intervention, totally new intervention, you have your own idea regarding that intervention that is currently not available in the market, that is not currently done by anyone else in the market, go for double control design. It will help you to control all kinds of effect, because this is the intervention that you have a copyright. Suppose you have some copyright intervention, you have some intervention that is patentable intervention, then in that case you control all kind of effects which are associated with your study. And the double control design is indicated in such cases when you have a novel study, you have a novel idea. Okay, the idea which is totally new, the idea which is patentable, the idea from which you can get the copyrights. Suppose you have such kind of idea, control all kind of mistakes, control all kind of errors in your study by adding one more control design. First, you have to identify. Okay, first you have to identify what are my extraneous variables, what are my chance variables, what kind of effects, whether reactive effects, maturation effect, regression effect, placebo effects, whether they are associated, what kind of effects are associated. Okay, all that you identify, and then you add double control design. Okay, so here we have a study population, intervention in the experimental group. Okay, control group, we do not have any kind of intervention. Active intervention means we do not have a intervention as our experimental intervention. Whatever we want to study, that kind of intervention is not present. And in control group also you have a control. You just want to control the impact of this maturation, regression, placebo or reactive effect. Okay, so you do not have your active intervention in these groups, and you will follow up the population for particular period time t, right? And at the end you will assess the impact. Assess the impact in all these three groups. From experimental group, total experimental group, you will minus the impact of extraneous and chance variables from group control group 1, and you will subtract the impact of reactive, maturation, regression or placebo effect from group 2. So what you are doing, you are subtracting total impact of experimental group. Again, total impact of experimental group minus extraneous or random chance variable impact in control group 1 minus random this reactive, maturation, regression or placebo effect in group 2. Or one more way of doing it is the impact of extraneous variables and random or chance variables in group 1 plus impact of reactive, maturation, regression or placebo effect in control group 2. You first add it, and then this entire impact from both the group added, you subtract from experimental group. Means you will get pure impact of your intervention on dependent variable.
Control group 1 will be of 5 years and control group 2 will be of 10 years, right? Yes. Okay.
Because here which effect applies, maturation effect is applicable. All the other effects may not be applicable, like there might not be reactive effect. There is possibility that reactive effect may be there, may not be there. Regression effect may be there, may not be there. Placebo effect may be there, may not be there. But definitely maturation effect is there. This example is related to one maturation effect. So you have to identify what kind of effects you have in your study. Okay, I will tell you in simple words. Double control design, what you have one experimental group where you want to assess impact of your independent variable on dependent variable in simple terms that you are aware. Experimental group. Control group 1 is a group where you will control the impact of extraneous variables and random chance variables on dependent variable. That is group 1. Group 2 will control the impact of reactive, maturation, regression and placebo effect on your dependent variable. So you want to eliminate, what you want to eliminate? You want to eliminate random chance variable effect, extraneous variable effect, reactive effect, regression effect, maturation effect, placebo effect. That everything you want to eliminate. How will you eliminate? First, you will calculate total impact in experimental group. Total impact in experimental group, suppose value is 100. Okay. Now you have control group 1 where random and chance variable and extraneous variables are active. Their impact is 20. So first you will minus that 20, remains 80. Then you have one more group, that is control group 2, where there is effect of reactive effect or maturation effect or any one effect. Suppose there is maturation effect in my example. So that impact is 20. So again, I subtracted 20. Now my value is 60. So previous value in experimental group was 100. Okay. So previous value means that is total calculated value. But whether it is true value, it is not true value. Actual value is 60. How I arrived 60 value? I subtracted the 20 value from control group 1, where the effect of random or chance variable and extraneous variable is controlled. So 20 minus is controlling the effect of random variable, chance variable and extraneous variable. Remaining 20 is the effect like reactive, maturation, placebo effect or regression effect, any one effect. In my example of children, it is maturation effect that is contributing is 20. So again, I subtracted 20 and the actual value, true value What is your objective? Your objective is to assess true impact of independent variable on dependent variable. So final 60 value is a true impact of independent variable on dependent variable. Actual value after experiment you got is 100, but that is not true value. That is not true impact. True impact is 60. Yeah, after subtracting the impact of all the control group 2, experimental group. So those who are from health science background, they must have seen the clinical trials. They have always done in such a manner, double control design. Most of time they are done in this manner, double control study design. Okay.
Sir, in second control group, we are not collecting a pre-test data, right? We are collecting only one data for the second control group. So to
Pre-test data
reduce the
is
effect
not.
of reactive and regression effect.
See,
Remove the
pre-test data may not be useful. Why it is not very useful? Because what is the purpose? What is objective? We want to eliminate or control reactive effect, maturation effect, regression effect, and placebo effect. That is the objective. When that is the objective, why we should waste our time in collecting the data related to that particular group? Rather than taking pre-test data for control group 2, we should focus only on the effect of these reactive maturation or regression effect. Okay, so we should focus on the objective. Otherwise, it is a wastage of resources. All kind of resources will be wasted. Anything else? Anyone? Comparative design. Next is comparative design. Comparative design means you are comparing something. You are comparing something means. Now I will give you example, live example. Before Corona outbreak, we used to take offline lectures. All students, they used to come to university campus and we used to have lectures that were offline lectures. During Corona, we had online lectures. All the lectures were totally online. And now I am taking online plus offline lectures. Like few students were coming here and few students are joining from distance, like they are joining through this online platform. Now there are three teaching modalities here. First teaching modality is offline teaching. Second teaching modality is online teaching, and third teaching modality is hybrid teaching, offline plus online. So now I want to study the impact of these three teaching modality. Teaching modality A is online, offline, teaching modality B is online, and teaching modality C is hybrid. Okay, offline plus online. So I want to assess which is the best way, whether online is best, offline is best, or online plus offline is the best. If I want to assess the impact, I will create three groups. Already there are at least two groups here. Okay, one group that is offline, hybrid group is already we have. Okay, online teaching we already did in Corona. So we have a data for that. And offline we already had conducted before 2020. So, okay, again, we have data for that. So we can compare these three teaching modality. And when we do such kind of experiment that is called as comparative experimental study design. What we are doing, we are comparing three modalities. We have here three active interventions. All are active interventions. I want to assess which is the best modality. Okay, suppose university want to assess whether it is offline teaching, online teaching, or offline plus online teaching, which is the best way, because they want to implement in for the future. So in that case, university can have like we will finish our lectures in next 3 months. This is hybrid mode. Okay, so 6 months of data I have for offline, 6 months of data for online, and now 6 months of data we will collect for offline plus online. Okay, and we will compare all three and we will arrive at conclusion. Teaching modality A is better, or B is better, or C is better. Okay, among these three, which is the best modality, so that university wants to implement in future. So when you want to have such kind of interventions where all the interventions are active interventions, here there is no passive intervention, right? There is no passive intervention. I can alter my study. I can alter my design in such a way that suppose there are 30 students in your batch or 35 students in your batch. I will divide your batch into three groups. Okay. So my arm A or group A will be the students. I will ask them to attend offline. I will take separate lectures, same lectures, separate lectures. Group B, they will attend online, and group C, they will attend offline plus online. So 10 in each group. Okay, group A online, group 2 offline, group 3 online plus offline. And I will assess the impact. How can I assess the impact? I will give you questions after completion of these coursework lectures. I will give you questionnaires and I will assess the impact based on the answers you provide or based on your level of understanding. Okay, how much you understand, or I will give you assignments. Okay, based on those assignments, I will understand which is the best treatment modality. So I can select certain variables. I can have variables 5 to 6 variables, and based on those variables, I will mark it, which is the best treatment modality, or which is the best teaching modality. Okay. So
marketing, the conventional advertising, then digital marketing.
Most commonly used, yeah. You have, like, you are from management background, so you have most commonly used experimental study design, comparative experimental study design. If you see double control design and control group design, these are most commonly used in health sciences. Comparative design most commonly used in technical sciences, or you can say management, the science of management, or social sciences also. They also use this comparative study design. So you can have two active comparators. Just now she told, like, instead of, if you don't want to take control group, you can use comparative study design. So your drug, one component is experimental group 1, second is experimental group 2, and third is experimental group 3, and she can compare. Similarly, in your case also, then that will be your comparative study design. If that is not used as a standard comparator, if that is not used as a standard control, you can use that as a comparative study design. Means you have arm A, arm B. You just want to compare which is the best arm, okay, which is giving the best results for your patients. That is your comparative study design. This you can do. This you can do. But try to add control group. If you have some effects, you add control group. There is possibility of, like, you try to find out the effect. There is no harm in adding. There is no harm in adding a control group, because you are experimenting with humans. So when you are experimenting with humans, try to reduce all the errors in the study.
Sir, I have a doubt, sir. The example which you had given just now about the online and offline classes. Sir, the students are not remain same for the study. So how would we address when we are dealing with the human population? How we can negate those things in the experimental studies?
Actually, I didn't get your question.
Sir, ये जो बच्चे हैं offline वाले और online वाले, are they from the same social oblique economical background, or in the same school, or with the same IQ level? There are so
नहीं,
many.
आपका तो कोहर्ट ग्रुप है. आपका तो कोहर्ट ग्रुप है. कोहर्ट मीन्स सेम, आपके कैरेक्टरिस्टिक सेम है. What are your common characteristics? All of you belong to a same class. Same class means what? PhD batch or particular batch. So you are all enrolled for a PhD program. You are a one cohort group. Okay, cohort group means you have some special common characteristics among yourself. So I can use this study. See, this teaching modality is what I am telling. It doesn't matter what is your intellectual level, what is your this thing, but you have enrolled. There is some common platform. Why you have enrolled for this particular program? Because there are certain common characteristic among all of you. That is common, so you have enrolled for this program. It doesn't matter what is your background, what is your socioeconomic setup, what is your intellectual level. It doesn't matter. That is already tested. After testing, you have come to this platform. So you have already a cohort group, already common characteristics you have. So I can conduct this study. Maximum I need to have matching. Okay, matching will be the next part. So why do we need, like, suppose matching may not be required for this kind of study, but suppose you have 30 people in batch and I want to assess the physical fitness of all of you. Suppose I conduct 3 tests. One is swimming, second is running, and third is some athletic game. So in that case, I should have matching among you people. Like, there are people who are ranging from maybe 28 years to 50 years or more than that in this group. So I should have a group based on, maybe I should first study physiology based on the physical fitness. So I can have a group between 20 to 30, 30 to 40, 40 to 50. That way I can have 3 groups. I can include people on that. Then again, among 20 to 30, I can have male versus males, female versus female. Swimming capacity of males and females you cannot compare, or athletic capacity of males and females you cannot compare, because skeletal mass is different for males and females. Okay, muscle tissue mass is different for males and females. So you cannot have that comparison. So matching we can do, and that will help to reduce the bias. Okay, but you already are a cohort group.
Yes, sir. Good point.
So I'm not doing a wrong experiment, but I can reduce some bias. Like in this study where I want to assess a physical fitness of your batch, then I should match for your variables. Like for your age, you cannot have a person like who is 25 years of age against 50 years of age for swimming capacity or for running or some other athletic capabilities. Okay, that will totally be different. because aging is a factor. So that will reduce your other capabilities. Okay, right? So I should have a person who is 25 years that is running against person who is of 26 or 25 years of age only. Okay, so the comparative design to compare the effectiveness of different intervention modalities, and in such situation, comparative design is appropriate. So whenever you have multiple interventions, more than one intervention, just now two students, they give example, they have different interventions. Okay, they want to assess the impact of different intervention. So you can compare. They can take as a standard control, that is a control group design, that is another story. But in comparative design, when you have multiple interventions, multiple active interventions, then in that case you can use this comparative design. Study can be carried out either as experiment or non-experiment. Okay, experiment means you have active intervention, right? Active intervention means you are actively introducing these three treatment modalities: online, offline, and hybrid modality. Okay, this is experimental study design. But if I already have a data, like suppose offline already I have a data before 2020, online I already have a data of 2020, and after 2020, there are few batches already happen, okay, during 21 or 22. So that may be hybrid mode. So if I already have a data that is available with me, in this case, I need not have to have active intervention because data is already available. Effect has already happened. So I can conduct it as a non-experimental study design. So I need not have to do it as a experimental study design. So comparative study design may be experimental or non-experimental. You can conduct in any way. You can conduct either in experimental. If I want to conduct in experimental way, I have to make three groups: group A, group B, group C. Group A online, group B offline, group C offline plus online. If I want to do it in a non-experimental manner, I should collect the data offline before 2020, online during 2020, and online plus offline after 2020, right? So that becomes my non-experimental design. There is no active intervention, data is already available, effect has already happened. So same example here I have given. Imagine you want to compare the effectiveness of three teaching models A, B, C on the level of comprehension of students in a class. So I just gave example of your class. This is another example, like teaching model A, teaching model B, teaching model C. So I just give teaching model A maybe online, or B maybe offline, and C maybe hybrid. Okay, so we are comparing it for your batch. What?
Collect the data.
We have active intervention. We have a cause which is introduced, and that cause will have its effect on dependent variable in the form of outcome variable.
Second option should be only.
You can take any like conventional teaching modality, like when Blackboard people used to have, like in our childhood days, we used to have blackboards. Our teachers used to. Now there are digital boards also. Okay, so blackboards, digital boards, or we have online boards also. Like students are sitting at home or kids are sitting at home, and there are online boards where they can also write and the teachers also can write. Okay, so impact that way you can assess. In our days, like in our childhood, we used to go to school, then our teacher used to see what is written on our paper, or they used to write on blackboard. Okay, we used to follow them, or they used to see the whatever is written. Now if it is online methodology, whatever is written by the student, that is reflected on the screen. Okay, so you can compare which is better, whatever conventional methodology through which we have gone, or the current methodology. Next is match control experimental design. So match control experimental design, just now I gave you example. Suppose I want to assess the physical capabilities, athletic capabilities of your batchmates or your entire batch, 30 people in your batch. Okay, so I can conduct it as a match control experimental design. Means I should match people for age, I should match people for gender. Females should run against females, females should swim against females, males should swim against males, or males should run against males. Okay, so you cannot have a match, maybe football match or cricket match for males versus females. There you cannot have assessment. Okay, you will not have two assessments. So here you have to do matching for certain variables, age, gender. Okay, that matching is essential for my example. Okay, for whatever is applicable for your study, you can match, but match few variables. You cannot match all the variables. You cannot have all the variables. Like there are different peoples from different background. Maybe some people having some diseases, or maybe some people having some childhood diseases or current adult diseases. Okay, so you cannot match everything. It is not possible to match everything to compare the physical capabilities. I am matching the basic variables. Which are my basic variables? age is my basic variable. Okay, my this gender is basic variable. So these two things in this case are appropriate matching. But if you start matching everything like profession wise, if you match them how much time they work in a day or how much people exercise, it is not possible. Like how many people they are regularly exercising. Yeah.
Compare. Physically not compare, but intellectually we can compare.
See, like if you start matching every variable, then it will create a problem. Then you will have more this thing errors in your study. So no need to match all the variables. Variables which larger variables which are going to affect your dependent variable. So those simple variables you can match. So comparative groups are usually formed on the basis of their overall comparability with respect to relevant characteristics in the study population, such as socio-economic status. Now, for your batch, I need not have to match socio-economic status. Why? Because it is not a social study. I am assessing the athletic capability of everyone. Socio-economic impact is not important here. If somebody is having social issue, if somebody is dealing with a social issue, then in that case, they can have matching for socio-economic status. Here it is not required, or the prevalence of certain condition or the extent of problem in the study population. Like extent of problem means age could be a problem. You cannot ask a 50 years person to run against person who is 25 years of age. Okay, so this way you can match, means you can match a person of 25 years against 25 years and 50 years against 50 years. Okay, this type of matching is important.
It feels like reality shows.
You can
singing, dancing.
Yeah, definitely. Because see, you cannot have a person who is 10 years of singer and who is mature singer. Definitely the voice will change over a period of time. Okay, there will be maturity in voice. So you cannot expect the same thing from both the candidates. Matching increases in difficulty when carried out on more than one variable. So don't go for multiple variables. Just now I spoke like for your batch, when I want to assess athletic capability or maybe physical capabilities, so I just have to match age and gender. That is sufficient. If I start matching everybody's working hours, who is doing regular exercise, who is not doing regular exercise, who is suffering from some diseases. So if I start matching everything, it will increase difficulty in assessment of the data, and I will myself introduce errors in this study. Okay, so no need to have so much of extensive matching.
Only one important things.
Important variables which are important for your study. Like if I do not match age, that is not justifiable. Okay, if I do not match gender when I am asking you to run, so or I am asking you to have some match, football match or cricket match. So in that case, males will play against male, females will play against female. Okay, so that is important variable here, because this is a situation. For your situation, which is important variable, you match that variable, the most important variable that should be matched. Otherwise, it will introduce error. Okay. If in my case, if I have a match, suppose football match, males are playing against females, then definitely there is a lot of errors. Okay, because physical capabilities or muscle mass is different for males and females, so you cannot compare that.
Sir, I just wanted to clarify
Is
something.
important in this case. Yes, go ahead.
So actually, in many of the textbooks, the word random distribution between two groups is also mentioned. So I just wanted to know if I'm trying to match the two groups, or I'm distributing the population that I have between the two groups based on these criteria. So let's say if I have a 50-year-old patient in one group, I make sure that there is the person I'm placing in group B is also in the 50s. Or if I have say 50% of females in one group, then I make sure that there are 50% females in the other group. So if I'm doing this, then am I still uh, staying true to the random sampling, or have I sort of avoided that rule?
Suppose I will give you example, my example only.
Hmm.
I got your question. Now suppose I want to take a test of swimming. Okay, you all 30, I have divided your batch into 3 groups, 20 to 31 group, 30 to 41 group, 40 to 51 group. Okay, I have 3 groups.
Okay.
I will take you to swimming pool and I will ask you to jump. But who will jump first? I want to assess. Okay, if I want to ask one by one, there are 10 people in one group. If I want to ask one by one, you enter into the pool or you jump into the pool. To whom I will prefer first? Okay. Should it is based on random or it is based on selective sampling? Always go for random sampling. Among 10, I will just prepare 10 cheats and I will ask to take out those lucky draw method. Okay. Or cheat method. By cheat method, I will ask whosoever's name come first, that person will jump first. Otherwise, it should not happen. See, why that person, why it is done in a randomly way? Because whatever is happening with the first person, others are observing. Means each and every person is getting equal opportunity of have that observation. Who will be first and who will be last? Who will have maximum observation and who will have least observation? Like because of observation, we will reduce the errors. Okay, so that opportunity is equally distributed. Random means what? Randomly I am picking it. Each and every person in a population is getting equal opportunity of getting either selected or non-selected, or getting either first or last.
Okay.
So random processing is important aspect. When you are doing experimental study design, it should be random. Don't go for purposive sampling for experimental study design. It is not qualitative study, it is a quantitative study design. So random is the integral part of most of quantitative study design. Definitely in qualitative study, like suppose I want to assess the mental or some emotional impact on people who suffered from Bhopal gas tragedy. In that case, I can have a purposive sampling. I need not go for random sampling. But when I am checking the capability or I am asking you to jump out of 10, who will jump first in swimming pool? If I want to decide that, it should be based on a lucky draw method, or you create the random numbers and based on random numbers, you allot who will jump first and who will jump last.
Okay. No, only, I mean, not while selecting the number of subjects from the sampling frame, but while distributing them into two groups, I was saying. So that distribution, if I'm using some criteria for matching, then does that mean that that random distribution is not happening now?
Random distribution you can have only on a similar group of population. Suppose
It's a
I will tell you
homogeneous
example,
group.
exactly same example what you asked. Suppose I want to assess the impact of 3 teaching modalities. This is experimental study design, active intervention is there. Now in this case, there are 30 students in your batch. I can randomly select for group A, that is offline method, randomly select for group B, and randomly select for group T teaching modality, online, offline, and online plus offline. That is possible. Your age might be different, your intellectual is different, but you have in one group, cohort group means you are in one batch. It is one school kind of thing, or it is 1 year. Okay, so you have enrolled for one particular program, and you are selected based on some common characteristics. So here randomization is applicable. Randomly I can apply it.
Okay, okay. So it should be a homogeneous group for the random distribution too.
When it
Based
is
on
homogeneous
some.
group situation, this is homogeneous group, this is cohort group. But when it comes to a swimming, I am not doing the randomization for a whole group. I am doing among the selected 3 groups. Okay.
Okay. Okay. Okay, sir.
It depends on the situation. Yeah. There is one more design. We were talking about placebo effect. So this placebo design has come from medical literature. It was extensively used in medical literature. So placebo effect means what? Since it has come from medical background or medical effect, I will give you medical example, treatment example. A patient's belief that he or she is receiving treatment can play an important role in his or her recovery from an illness, even if the treatment is ineffective. The psychological effect is known as placebo effect. So placebo effect means what? When you want to assess, specifically in medical fields, when you want to assess the impact of one drug or one medicine. So how will you assess the impact? You want to reduce the psychological phenomena or placebo effect. Placebo effect means what? Sometime you are suffering from some illness. You just go to doctor, you speak to doctor and you start feeling better. So that is a feel good effect. That feel good effect is what? It is a psychological phenomena. Your disease is not cured. You are not totally cured. You are not taken any medication, but it's a psychological impact. It's a psychological impact because you spoke to a person who is expert in that field. So that is called as a placebo effect. So in medical study design, specifically in clinical trials, what they do, they have 2 arms. Arm A will receive the drug, arm A will receive the treatment, and arm B will receive similar treatment. Suppose for arm A, blue colored medicines are given. Arm B will also receive blue colored medicine, but that blue colored capsules will be empty. There will be no active drug ingredients inside the capsule for placebo group. So placebo group will only have that capsule, which is inert, which doesn't contain anything. But capsule group A will receive the actual capsule, experimental drug. So whatever capsules are given, which are of blue colored capsules for group A, it will contain active drug molecule. But the similar colored, blue colored capsule of same size, same dimensions, same looking capsules which are given to other group, placebo group, it will not contain any active drug molecule. Means it is just psychological phenomena. How much improvement? So that improvement you have to reduce it, subtract it. Suppose there is improvement of X amount. That X amount of improvement you have to reduce it from your experiment design. So you will get actual impact of your drug. One impact is psychological impact. Psychologically, how feel good effect you have. Okay, that feel good effect you have to subtract from your total impact of experimental group, and then you will get actual impact of your experimental group, right? So patient's belief is that he's receiving treatment can play. So patient is not aware. The placebo group patient is not aware that there is no medicine inside it. He is feeling that there is medicine inside it. Means it's a psychological effect. He is taking the medicine thinking that there is active drug molecules and I will get cured. But actually there is no active molecule. The active molecule is missing. But it is just a psychological effect, psychological impact that I am taking medicine or I spoke to doctor, so I will feel better. Okay, so that psychological impact is taken care in your study by this placebo design. So whenever you have this placebo, now it is used in all sciences. It has came from medical science. So I give you example of medical science. Now it is used in most of sciences. Maybe management sciences, you can use placebo design. Okay, so even for assessment of some particular products. Suppose you have one industry and you want to assess the impact of product. So you can have similar product, similar labeled product you can distribute among the people. Like suppose there is standard, which is very favorite product that is available in the market with a similar name, similar things, similar everything. You can introduce another product and you can see the impact. How much is the psychological impact? So this study design is now extended to other sciences also, maybe social sciences or maybe management sciences. It has but initially it was introduced in medical science. Okay, so you have experimental group where treatment is given. Your placebo group where nil treatment means no treatment is given, and your control group, definitely you have a control group to uh, take care of the effects of extraneous and random and chance variable. Okay, it is similar to your double control. See, there is exact similarity in double control design. In double control design, we have experimental group, control group one that was for controlling random effect, chance effect, and extraneous effect. And control group two was for a reactive effect, maturation, regression, and placebo effect. Okay, so placebo design I have taken separately because it was used conventionally. It was taught and conventionally it was used in medical science. So just I took it here. Okay, so your control group will control the extraneous effect. Placebo will act as a control group 2 here. Okay, so it is similar to your double control design. Okay, only you have a placebo, the name which is given, that is nil effect, means it is just psychological impact that is assessed. So treatment impact, how will you do? Experimental group minus placebo group minus control group. That will give you actual impact in experimental group of independent variable on dependent variable. Double control design. Placebo means here also we are controlling. Extra control group or control group 2 is taken to control the placebo effect also, maturation, regression, placebo, and reactive effect. Okay. So here we are done with experimental study design. Any doubt in experimental study design?